In this last video in section 4.3, let me tell you about some properties of the definite integral. The first integral has to do with the integral of a function when the two endpoints are the same. So the integral from a to a. Let's draw a picture of what that could possibly mean. Here's our function y equals f of x. Here's a. And I want the area of the curve between a and a. Well, I suppose this would just be one very skinny rectangle that has a base of 0. So if I take base times height, then that's 0 times f of x, which is 0. And in the future, anytime you see an integral where both endpoints are the same, you can simply say that the answer is 0. Now, the next one is almost in the form of a definition. But occasionally when you're working problems, you'll see the integral from b to a of some function, where b is actually larger than a. So it's as if you're trying to integrate from right to left rather than from left to right. What that does is it reverses the value of the integral. So the integral from b to a of a function is the opposite of the integral from a to b. So if you see something odd looking like a 3 on the bottom and a 1 on the top, feel free to swap the 3 and the 1 and just put a minus sign in front. Now the third one is one that's going to look kind of odd. But let me draw you a picture first, and then we'll write it down in symbols. So here we have the integral from a to b of some function. Say this is a, this is b. Here's the function. And let's say that c is some point in between. Then notice that C is going to divide this region into two smaller regions. We can call them R1 and R2. So what this third property is saying is that the total area between A and B is equal to the area between A and C plus the area between C and B. So the area of the big region R is equal to the area of R1 plus the area of R2. So in symbols, the area between A and B is equal to the area between A and C plus the integral, or the area, between C and B. For a couple of more properties, the next property we can call the constant multiple rule. And is similar to the constant multiple rules we've seen before. The definite integral from a to b of a constant times a function of x is the same as the constant times the integral from a to b of the function. So you can take a constant and factor it in front of a definite integral. We've seen similar properties for limits and for derivatives and for antiderivatives. And last we have a sum and difference rule. That says that the definite integral from a to b of f of x plus or minus g of x is equal to the definite integral of f of x plus or minus the definite integral of g of x. Now, some things to notice that I'm not putting on the list. There's no product rule and no quotient rule. So let's wrap up this video with an example from the book. This is problem number 42. Here they give you two pieces of information. They tell you that the integral from 0 to 3 of f of x is equal to 4, and the integral from 3 to 6 of f of x is -1. And here are some of the things they ask you to find. They ask you to find the integral from 0 to 6 of the function. Well, using the rule number 3 that I just gave you, this is the same as the integral from 0 to 3 plus the integral from 3 to 6. I'm being lazy about notation here, which will be 4 plus -1, or 3. In part B, they ask you to find the integral from 6 to 3 of the function. Here, notice that this one looks similar to what I have here, only the endpoints are swapped. But the integral from 6 to 3 is the opposite of the integral from 3 to 6. Again, being lazy about notation. This is the opposite of -1 or +1. In part C, they ask you to find the integral from 3 to 3 of this function. Well, since the two endpoints are the same, that integral is 0. And last, in part D, they ask you to find the integral from 3 to 6 of -5 times the function. Here I have a constant multiple of -5, which can be factored in front. And the value of the integral from 3 to 6 was given to be -1. And -5 times -1 is +5.